Good morning, everyone. I see people are already connecting to the webinar, so welcome everyone to this webinar, this recycling of plastics towards a more sustainable plastic treatment in 2030. We will give just a couple of minutes to start this webinar. I see people are still connecting, so let's wait a couple of minutes more to give enough time to people to connect in case anyone is experiencing problems with their networks or so. If someone maybe is experiencing problems with the connection, we certainly advise you to try to do it through the browser instead of using the Zoom app because it usually gives problem to connect. So if you can try to connect through the browsers, if you know anyone who's experiencing problems to connect, please tell them that they could use instead the browser with a link to connect, and that should be working. Well, I think maybe we can start now. Welcome again to this Recycling of Plastics webinar towards a more sustainable plastic treatment in 2030. Through today's session, we will be having several presentations for 2 hours. But obviously, we don't want to just keep it in presentations. This is an interactive session, and we certainly would like you to participate as much as possible. I don't know if you are familiar with the Zoom platform. We will provide you a couple of instructions now on the presentation, just for you to know what's expected from this session. The first thing that I would like to say is to introduce myself. My name is Mariana Fernandez. I'm Head of Communications at Sustainable Innovations. And today I will be welcoming this session and trying to introduce our panelists and obviously to encourage you to participate as much as possible and to try to give this session a smooth participation. Probably you are wondering if this session is going to be recorded and available afterwards. Yes, it certainly is. We are recording the session and it will be uploaded to the project's website afterwards. So if you are not able to participate during the whole session, you will have the session available on the project websites. And we will send you a follow-up email with all that information. A couple of instructions just to keep it clear. Please don't activate your microphone or video cameras unless we give you the permission. So you can see now on the screen the main panelists that we will be speaking today. Another instruction is if you are willing to participate, as I mentioned before, this is not just presentations. We would like you to participate with us and to ask as many questions as possible. Please raise your hand so we can activate your mic and you can ask your question. Obviously, you have also the possibility to ask your questions through the chat. A brief summary of what we'll be doing today. As I said earlier, we have 5 presentations today. We will be going through several ways of recycling plastics, of the future technology of recycling plastics. The first presentation of the session will be the NONTOX project. Our main speaker will be Mohammad Saad Qureshi. He is senior scientist at BTT, and he's also the coordinator of the NONTOX project, a project addressing some technologies mainly based on recycling hazardous plastics. Then we will go through the next presentation. This is the PLAST2bCLEANED project. The PLAST2bCLEANED project aims at recycling ABS and HIPs, bromine and antimony trioxide from waste electrical and electronic equipment plastics. This will be led by Esther Sondervan. She is Senior Consultant Plastics at TNO and also the PLAST2bCLEANED coordinator. Following this presentation, we will be having Irma Konsari, project manager at Fraunhofer Institute and a coordinator of the Creator project. The Creator project is addressing this plastic recycling by the collection of raw materials and removal of flame retardants. Next presentation will be led by Thomas Diefenhardt, Associate Scientist at Fraunhofer IVV, and Circular Flooring Coordinator. The Circular Flooring Coordinator, the Circular Flooring Project, aims at recycling PVC from post-consumer flooring waste. And the final presentation of the session, and then we will go to this panelist conversation. We will be having the project REACT. REACT addresses the management of waste acrylic textiles coming from outdoor awnings and furnishing. And this presentation will be led by Roberto Banucci, a multi-sectoral R&D department manager. Finally, as I said before, the idea is to have an interactive discussion between the panelists, and based on the questions you are going to ask us, between the sessions, I didn't introduce that, but you can anytime ask questions, and we will be addressing those to the speakers so they can answer them afterwards. If there are many questions that are finally not going to be able to answer them during this session, we will compile all of them and try to provide an answer after the session. Finally, as I said before, we have 5 projects addressing the plastic recycling challenge. Over there, you have more information. We certainly invite you to follow all those projects through their websites and social media channels, but we will provide those information during the presentations, so it's easier for you to follow the channels. And now I will mute myself, so I leave the floor to the first speaker. But before we do that, we would like to know more what are your interests in this webinar, and how familiar are you with this webinar topic? So a couple of questions for you, just to answer how familiar are you with the webinar topic, just for us to know if you are an expert in plastic recycling, or is it the first time that you encounter this challenge in a technical way. We will give a couple of seconds for you to answer those questions. Okay, I hope you already answer that questions. Now, I will leave the floor to Mr. Mohammed Saad Qureshi, Senior Scientist at BTT, and he will be speaking about NONTOX. Thank you very much, and see you later.
So yeah, hello, good morning. I hope you are able to hear me well and see the presentation. So yeah, my name is Mohammed Saad Qureshi, and I work as a senior scientist in VTT. And today I'm going to be telling you more about what is NONTOX project and what are the toolbox of these technologies that we are using to basically recycle the hazardous plastics in general. The agenda of my presentation is basically that I'll go through very shortly what is NONTOX about, what is the challenge that we are trying to target, and how we are going to address that challenge. So basically the NONTOX concept, and what are the potential impacts that we aim to create with the widespread technologies that we are developing in the NONTOX project, and then some words about what are the policy recommendations that we have identified with the with our investigation into the framework of the legislations and regulations. So yeah, to the next slide. This is briefly how NONTOX is composed. Basically, it has a budget of approximately 5 million euros, and the duration of the project is from 2019 to 2022. And we have approximately 12 partners from 7 European countries, including players from all the different parts of the value chain in the whole concept. So we have a collection scheme, so the manufacturer representative, Arian from Italy. Then we have waste treatment plants from Sweden, Stena, Coolrec from Netherlands, Tree from Italy, and Gallia Polymers from Spain. Then we have research technology organizations participating in NONTOX, and those are Fraunhofer from Germany, India from Spain, IMPLAST from Spain, VTT from Finland, and Norway is participating with Norner. And then we also have two universities involved in this project. So University of Vanvitelli from Italy, and Aalto University from Finland. So what is basically this challenge? Basically we want to save these valuable plastics which are now sent to incineration or landfills. But if you look at the whole picture, how much actually is this plastics that we are after? How much is the potential waste that is sent to incineration each year in Europe? That is the one of the biggest questions. If you press the pointer, there's these animations. So how do we get to new products from these waste materials? So that is the question. Yeah, please. Yeah, can you press that bit again? So that is the question. So we are looking at the toolbox of different technologies that we can be using to valorize this plastic waste which is going to incineration currently. So approximately we have estimated approximately 3.5 million tons of plastic waste coming from these streams are currently now mistreated in Europe each year. Now, if I talk about a little bit more about what is the solution or the concept that NONTOX is developing. So we are, as you can see it on the screen, here is the scheme of the NONTOX. We are looking at three different three different waste streams, including waste, electrical and electronic equipment, construction and demolition waste, and end-of-life vehicles, and particularly the plastics from these streams. The first step in this value chain is the sorting. So how do you basically sort the different types of the polymers, and how do you classify them in between what is recyclable and what is not recyclable, and what kind of impurities do these plastics contain? So if you press that pointer, yeah, so this is the first, let's say, the tool in the toolbox of technologies. So this is where we are developing at VTT intelligent sorting of the different polymers using active hyperspectral sensing technique, in which we can classify the plastics containing bromines or the flame retardants in them. So the next step from this sorting is the recycling technique, and in this box you see that there are a couple of these technologies called Creosote technology and H2020 technology, which we call as physical and mechanical recycling technologies. And these are the ones that are the core technologies used for the recycling of hazardous plastics. And Fraunhofer in Germany and IMPLAST in Spain are looking at these technologies for recycling the plastics containing flame retardants. Uh, Now, as you can see that from the main recycling box, there is basically one arrow going towards thermochemical conversion, which is basically the non-target plastic waste fractions. So if we broadly classify the plastics, we can say that there are the ones that are suitable for this recycling technology in Creosote and X2Clean, but then there are the ones which contain contaminants in which are basically not suitable for these technologies. So those non-target plastic fractions are still treated with thermochemical conversion technologies, and of course also the byproducts and residues coming from the main recycling technologies are directed to the thermochemical conversion technology. In this case, it is the pyrolysis, and the pyrolysis is the core technology which is now treating the most difficult residues, and it's developing at IMDIA in Spain and VTT in Finland. So with the thermochemical conversion technology, you can convert the plastics into valuable hydrocarbons. Uh, the arrow coming down from the main recycling technology are basically the recycled plastics, which can then be upgraded with the use of special additives to get to a point where these plastics can be used in high quality applications. So as you can see that we can finally go to applications where virgin-like properties are needed. So the recycled plastics from these technologies can compete in a very good manner with the virgin-like materials. So this is how we are trying to close the loop of the plastic waste by not letting any of the plastics move out of this whole value chain. To the next. And then if I talk briefly about what are the potential impacts that we estimate are, yeah, the potential impacts from the non-tox. So we see that approximately we are able to recycle with this concept approximately more than 2 million tons of these type of plastics each year in Europe. And then the next one is we estimate that approximately up to 74% increase can be estimated in the recycling capacity in Europe with the use of these non-tox technologies. And then we can also assume that with our approximations that approximately 2 million tons of greenhouse gas emissions can be avoided. We also believe that approximately threefold increase in jobs can be seen with the use of the non-tox concept in the recycling sector. Then I talk briefly also about the policy recommendations. So in the non-tox project, we had the task to basically investigate the landscape of the different regulations and frameworks and directives that are basically encompassing the whole non-tox concept, and how these type of plastic waste is currently handled, and what are the relevant legislations that basically affect the whole value chain. So we have looked into different regulations, POP regulations, REACH regulations. We have looked into ROS criterias. So after looking at all this great landscape of regulations, directives, frameworks, we have been trying to identify the gaps and in the current landscape, and providing us also with the recommendations how to move forward with such directives in the future, so that maximum plastics can be recycled. And the most important findings from this is from this investigation is that we found out that, for example, the current eco design legislations, they basically promote energy efficiency rather than material efficiency. So the processes are basically designed to conserve energy, but material efficiency has been missing. So that is also one of the key elements for the future, that in the future, eco design legislations, that could be one of the aspect that can be highlighted. The introduction. So sorry, can you go back? Yes, the introduction of the end of waste criteria for plastics is another bottleneck in this whole concept. And such introductions of this end of phase criteria will basically harmonize the EU markets. The key policy messages that we want to also give from our investigation is that eco design directives should also basically include aspects related to recyclability, which is basically that you design for and from recycling. And that is also one of the key things in future activities in the non-talks. We are still looking at development of a report based on the eco design criteria for developing guidelines, especially for ELV, V, and construction and demolition waste. And then we are also working on a report for the actions to basically classify what are the actions that are needed to enhance the circularity in this scenario with the hazardous plastics. And then the next slide is basically can you go to the next slide, please? Yes, this is just introducing to the NONTOX website, where we have lots of materials to be downloaded. There is different deliverables that we have produced in the NONTOX project that you can visit the website, and you can download these reports, comprehensive reports. For example, procedures for safe working with these contaminated materials, how the feedstock is distributed in Europe of such type, so mapping of feedstock. Then you can also subscribe to our newsletter and get information on the progress of the project. So basically that was, I think, all from the short presentation of NONTOX. And thanks for the attention. If you have any questions, please, go ahead.
Thank you very much, Mohammed. This was quite an interesting presentation. I saw we have a question, but before we go through that questions, we would like to remind that this is an interactive session, so please send us your questions through the chat. You can also raise your hand in case you would like to talk out loud. So please keep in mind this is an interactive session, so we wouldn't like for you to be curious about anything. And finally, don't ask your questions. The question that I was going to ask to Mr. Mohammed is, after seeing your presentation, I see a challenge here on how soon this technology of the non-tox concept do you think when will it could be commercialized?
So basically, we are not looking in non-tox in technologies which are really new. The reason I'm saying is that, for example, Creosote technology is already now in a demonstration phase. Pyrolysis technology is a very developed technology. The challenge actually has been in the non-tox project is how we can use these technologies to basically serve the purpose of removing these hazardous substances. So I believe that the technologies are quite ready for commercialization in a few years. With the non-tox project, we will be able to give the proof of concept that these technologies can well serve the purpose of this. And I think the technologies are quite ready for the next step.
Thank you very much. We also saw that you present those challenges regarding the policy implementation. Usually is a common challenge for all the projects that are addressing these innovative solutions. Do you think this is important to put something in common between the projects to address those policy recommendations?
This is definitely very important, and I think with the help of this cluster, with the projects working together, I think we will be able to make. Hopefully, we will be able to make a joint statement or a joint policy brief in which we can identify what are the key key aspects in the current legislations that needs to be, changed for a better future.
Thank you. We have still a couple of questions more. Thank you for participating so actively. We have technical questions here. Does AHS allow to sort by polymer and brominated flame retardants, SB, PB, etc. content?
Sorry, I didn't understand the question. Can you please say that again?
Yes, sure. Does AHS allow to sort by polymer and brominated flame retardants, etc.?
Do you mean the active hyperspectral? Yes, we are developing this technology, and so far I can say that we are through the mid of the project, and we have been able to achieve the efficiency up to 80% in classifying brominated flame retardant plastics. Yes, and we are still progressing with the technology and making it even better.
Thank you for your answer. And one last question, and we move on to the next presentation. There's a participant who's saying that he missed details on how much plastic from the feedstock can be recycled into secondary plastics, and how much today is already recycled in order to detect the untouched potential.
So currently, the current state of art is that brominated flame retardant plastics up to a certain threshold is sent to incineration. So it's not recycled at all. That is why the NONTOX and other projects now exist today, that we want to develop solutions to save these plastics. They are not recycled today because they contain these legacy additives, and I think with the help of these technologies being developed in these projects, we will be able to get back into circular economy a big share of plastics that is now sent for incineration and landfilling.
Thank you very much again. I see that there are more questions. As we are running out of time regarding the presentations time slot that we have defined, we will try to answer them after the presentations. Thank you very much, Muhammad. We will now move on to the next presentation, led by Esther Sonderbrand, Program Manager at TNO and Coordinator of the PLAST2bCLEANED project. Esther, the floor is yours.
Thank you, Mariana. So my name is Esther Sondervan, and I will present the PLAST2bCLEANED project. Next slide, please. And what is important is that the overall aim of PLAST2bCLEANED is to develop a human and environmentally safe recycling process for the waste electrical and electronic equipment, the so-called plastics. And this should be done in a technical feasible and also in an economic viable manner. So, and that, of course, in a sustainable way. And by doing the PLAST2bCLEANED project, we are closing 3 loops. And that is the loops of the polymer, the bromine, and the antimony trioxide. And in this picture here, that is there's presented how we doing that. So we start with the development of a mechanical pre-sorting technology, which is based on Raman and Lips. We closing the 3 loops for the dissolution technology. So those plastics that contain brominated flame retardants, they are going to the dissolution facility, and there we work on the superheated conditions, and that means that we work just above the boiling point of the solvent, and then we can separate the polymer, the bromine, and the antimony trioxide. And we're doing that for HIPS and ABS coming from plastics. Then the next step is the scale up and integration of all those steps for separation of the 3 components, polymer, bromine, and antimony trioxide. Then, of course, we do the performance testing of the products and the process. So check if they comply with the REACH legislation. And this, we're doing that also of everything from a point of 5, the system optimization for sustainability and economic viability. So actually, point 5 is not really at the end of the process. We're constantly checking all those steps if they are sustainable and economic viable. Next slide, please. So TNO is coordinating of this project, and we are doing this not alone. We're doing this with the Research Institute, Fraunhofer and Geiger. And what is important is that we connect the whole value chain to this project. So Coolrec as a recycling company, Ducam for the engineering, so the process equipment. Then we have Elex as a plastics producer of ABS. Electrolux is end user of the plastics. ICL for the bromine recovery and also the connection to the chemical industry. And for the antimony recovery, we have Campina on board. And of course, we have sustainable innovations for the destination and exportation, in which does Marianne today already an excellent job. So next slide, please. So here you can see the whole consortium. People are all working on this project in the pre-COVID time, so we could meet each other together at Fraunhofer ICT in Germany. Then the next slide. And here you see what the impact is, what we would like to gain with PLAST2bCLEANED. We have a desired recovery yield of above 80%, and this means that we can increase in Europe the recycling rate of weak plastics with 8%. So 40% reduction compared to the methods that is or to the incineration, which is now used for the plastics end of life. And what is important is that I already said we are closing 3 loops. So not only from the polymer, but also from the antimony and the bromine flame retardants. And this should end up in profitability for the chemical sector. Next slide, please. So here you can see the progress of this project. So first, as I already show you by the scheme, we start with the sorting technique. And there we worked mainly on to identify all colored polymers, including the black ones, which is really one of the challenging issues nowadays. And that we are doing for HIPS and ABS. So what we are now, how far are we now? We set up our equipment. We made a library also, and we are now optimizing for the colored and for the dark samples, and this is ongoing research. So then the next slide, please. So this is then the next step for the dissolution technology, in which we are going to recover the polymer, the antimony trioxide and the PFRs. And this is currently running at lab scale, and we are preparing to scale up to TRL 5.6. So at lab scale, we are now at about 100 gram scales, and we started with the preparation of test samples with known composition, and that we did typically made a variation of the sample. So both HIPS and ABS were used, and there are soluble brominated flame retardants and insoluble brominated flame retardants. So we use both flame retardants to check our process. And then the next slide, please. And here you can see some of the process. So on the left side, that is the semi-batch processes at 100 gram scale. Right is at Fraunhofer ICT, and currently we are setting up a larger facility at Fraunhofer ICT, which is up to 1 kilogram sample that can be prepared. And then the next slide. Here you can see some results of this project. What we see is already that the project is doing it quite well. So the bromine reduction, we almost reach the target, which is very, very good. And also for antimony, the target is reached. So for bromine, we need a bit, just a bit better, but I'm sure that we can do that in the coming months. So we made, based on these experiments we did so far, and that is over 250 experiments, we made our process flow diagram for the demonstrator, which is currently being built. And we checked all the junctions, what we have to make a decision about. And then the next slide, please. So as I already said, we do not only look at the technical issues of this process, but also for the economic and environmental assessment. And from the economic assessment, we already see that this process is in principle economic viable. And also from a sustainability perspective, we looked at the impact for the environment, and we did that in two ways. We looked at the product from a product perspective, as you can see there on the lower picture. One is the door from a washing machine, and the other one is the inner liner from a refrigerator cabinet. And that is from the product perspective, and also from the waste perspective. We just looked at the end-of-life treatment of 1 ton of free plastics, and then compare it to an incineration, which is done currently. So then the next slide, please. And here you can see some of the first results. So we're now performing an in-depth life cycle assessment, but this is just from the scan. And there you see that we see a clear improvement by doing this, by using the PLAST2bCLEANED process for HIPS and ABS. So this is the comparisons of the brominated HIPS and brominated APS compared to the municipal waste incineration, and that is with energy recovery. And here we looked only to the polymer, but we look now also in the in-depth scan also to the benefits of the bromine and of the antimony trioxide. Next slide, please. So then I'm coming to the end of my presentation, and I would like to finalize where I started with. I think with PLAST2bCLEANED, we are very good on our way to develop a nice process for the mechanical sorting technology. So the sorting of the different types of plastics, and do they contain brominated flame retardants or not. Then closing the 3 loops for the plastics that contain brominated flame retardants for the polymer, bromine, and antimony trioxide. The scale up to TRL5-6 scale, performance testing, so do they comply with the REACH legislation, and that all from an economic and environmental sustainable way. So then the next slide, please. If you would like to have more information, I would like to invite you to look at our website, www.plast2bcleaned.eu. Follow us at LinkedIn or at Twitter, and you can also subscribe for our newsletter. So thank you for your time.
Thank you, Esther. Very interesting presentation indeed. I saw that we have several questions on the screen. I will try to keep those till the end of the presentations, because they are more focused on addressing all the panelists, because they are general questions for all the presentations. But regarding the presentation, Esther, we have a question. An LCA, a life cycle analysis, is usually a challenge because there are several methodologies implemented along the projects. Do you think that a common methodology will help the analysis of the life cycle costing, and to put in common the discoveries for the projects?
So I think both environmental assessment and the life cycle costing, that is important for the project. Life cycle costing is of course important because then you know whether there is an economic benefit, and at least when you are going to scale up at higher scale, you need also investment of investors. So you need to have a business case how you can make business at the end of this. And of course, when we are making new technology, then we should be sure that it is also sustainable. Because if you cannot prove that, then the chances that you go from one now from incineration, which has also some benefits, because we can do the energy recovery and we can do some heat recovery from that, but it should be better than what we have now.
Thank you very much, Esther. We will continue with those questions we received during the panelists session. We will move on the next presentation. This is a presentation about the collection of raw materials, removal of flame retardants, and that will be done by Irma Mikonsari from Hofer Institute for Chemical Technology. Thank you very much, Irma, for joining us today. The floor is yours.
Thank you, Mariana, for the kind introduction. Yes, I'm honored to present you today the Creator Project and what we aim for there. As said, I'm Irma Mikonsari, coming from the Fraunhofer Institute for Chemical Technology. You can give me the next slide, please. So I will guide you in this session through the Creator Project. Firstly, telling you what we aim for in the project in the removal of hazardous materials, and then coming to our status in the moment in the project, what we have achieved so far, and then conclude with how our results are impacting the circular economy in Europe. Next slide, please. So this is how the Creator Project works and what we are aiming for. As the projects already shown before, NONTOX and PLAST2bCLEANED, we are also looking on the removal of hazardous materials from thermoplastic materials, and specifically on those legacy flame retardancies containing bromine. So where we start is the collection of the waste, and we do consider 3 different waste streams. One coming from the construction and demolition waste. They are looking on the EPS foams. Then we have the waste stream coming from the electrical and electronic equipment. We were also looking on the APS. And then the third stream coming from the aeronautic industry, where we are looking on PC thermoplastics. Those materials then enter the separation and recycling step, where we have a new identification step using the LIPS technology, as does the PLAST2bCLEANED project as well. So the laser-induced breakdown spectroscopy to detect the bromine-containing parts and the non-bromine-containing parts. And those containing bromine are then fed into our purification step, where we do a continuous extraction to remove those brominated flame retardancies in an extrusion line using environmental friendly supercritical CO2 and NADES liquids. Then, having those non-brominated fractions, we do label them for the later application, saying what content of bromine we do still have, and then of course giving the applicants further key performance indicators. So what the performance of that material is, for example, concerning the mechanical behavior or viscosity, what is very relevant for the later processing. And then we go even a step further to show how those materials can be reused. And for that, we do remodificate the materials concerning the needs of 3 different sectors. On the one hand, we are looking for automotive interior parts in injection molding. Then we have, once again, where we really close the loop, bring back the PS as an EPS to insulation panels in the building and construction sector. And then we aim for brackets in the aeronautic sector as well, which are 3D printed. This whole process chain, also aiming for a very economically feasible process chain, is combined by a research of a model for a reverse logistics chain to see which facilities we need where to be most economically feasible. The whole process on the purification aims to be shown at the end of the project in a kilogram scale at the materials APS, PS, PC, and maybe also PA. Next slide, please. And who are we? We are quite big consortium and have grouped a bit the partners along the activities they are doing. So in the recycling part of the project, we have covered those waste streams from the construction and demolition waste by Volbas. Then we have the VEE stream, also covered here with Coolrec and Relight. Relight is taking over by Tree, so you saw that partner already in the other projects. Then we have 2 partners who are capable of designing and manufacturing recycling equipment, which is Erema and Maschinenfabrik Otto Schuten. And furthermore, those partners are supported by research organizations like KAIGA doing the LIPS technology, Centexpel and Fraunhofer ICT being responsible for the extractive extrusion, and the CUNY Logistics University developing the model for the logistics chain. Then in the reuse of those materials, the automotive sector, interior sector is covered by Meyer, the cycle fiber being responsible for the 3D printed aeronautic parts, and DAW being responsible for those EPS insulation boards for the building and construction sector. And they are supported by the research organization CIDO for environmental friendly flame retardancies, TCKT being responsible for the development and modification of the injection molding grade of the materials for the automotive case. Fraunhofer ICT is here taking the role for the modification of the EPS polymer material, so the polystyrene for the insulation boards, and Centexpel is developing the 3D printing filaments. Furthermore, we have 3 partners looking more on the overall topics of the project. As said by Esther, the life cycle analysis and the life cycle cost analysis are very important for the project, and this is carried out by RW Energia. OFAM is guiding us through the legal framework in the project, and ITRP are our dissemination and exploitation managers. Next slide, please. So coming to the key results, and I have grouped them as well along the process chain we are considering. So here in the recycling step, exemplary 2 results where we have already prototypes existing. So on the top right-hand side, you see the LIPS prototype at KAIGA. In the front, the LIPS device itself, and in the back, the yellow box where we have a conveying belt and where we sort the materials on the threshold of 1000 ppm bromine. And for that, currently we are developing the models for the detection, and we are using here the VLS method, so the partial least square regression methods to classify the results concerning the concentration. Then on the right-hand side, in the bottom, you see an extrusion line, a bit longer one than usually used, where we do the extractive extrusion. And currently we are transforming the batch results, as you can see on the next graph, where we have already obtained quite good extraction efficiency is in the batch. These are now transferred concerning the process parameters to the continuous extrusion. Next slide, please. Then coming to the reuse, we have already here worked out quite a few pre-demonstrators, I would call them, using the non-brominated material from our stream. For the ABS, we have made those 3D printing filaments at Centexpel. The left one is the thicker one, the 1.75 millimeter strand, which is very commonly used in the 3D printing industry. But aiming for the aeronautic application, we need also a very fine filament, and Centexpel was able to produce a filament of 0.18 millimeters already for that application. Then we see the Crea part. This is an injection molded 2D part where Meyer is making feasibility tests of the process concerning the mechanicals and the aesthetics of that part, and both parameters have already passed the requirements, so already quite satisfactory results. Then on the right-hand side, you see these black bubbles. I don't know if you are familiar with that. These are the single particles from which your insulation board on the building is molded from. And what is done is that quite dense bulk bead is expanded into a desired density, and this is already done at DAW in a two-step process for long stored materials, which are quite hard to expand. And those have been molded also to an insulation board to test the insulation behavior. And both parameters are already passing all tests. So we are quite confident that we can use that in the process later on. And then the last diagram showing you that CDOUT is developing a bunch of different new flame retardants packagings where they are using mineral fillers like aluminium trihydride or maxanium hydroxide, also nanoclays or different metallic oxides to provide a tailored flame retardancy for the application, matching also the mechanical parameters. Next slide, please. And this is on our reverse logistics development. So we have set up the requirements for the creator process and how the logistics should look like. And in the moment, the Kernel Logistics University is developing a model how this fits together. So they are simulating the supply chain and they take into account the location and the size and number of the different recycling plants and what steps are carried out there to turn out to best possible economics. So it's a matter of if I do the whole sorting at one place or if I separate it into two, how big volumes I have to treat, etc. Next slide, please. And how is this, these results are impacting from the technical point of view as well as from the social and economic point. So in the technical, we are delivering a very precise separation systems for the bromine. And we are removing the legacy flame retardants from the polymers. And this will enable the increase of the recycling rate. And we have calculated that exemplarily for CUREC, for the VEE stream, that we will be able to recover with this technology up to 45% of today's waste fraction they have. So quite a huge amount of that, which is today, as already told by the other speakers, incinerated or landfilled. And this turns, of course, then later on to social and economic benefits. So recovering the petroleum-based materials and reusing them will, of course, make us more independent from those sources from outside Europe and decrease the imports and make us more resilient. And this will carry on to the more circular model for the plastics, especially the thermoplastics. And doing so and installing those plants in Europe, this will, of course, secure also these jobs in that sector. And on a longer term, of course, these technologies we have developed can be applied to other waste streams and other applications as well. So all in all, we are, of course, working on that the recycled plastics are not anymore called as waste, but that they are really a valuable secondary raw material. Next slide, please. And this is just the last part, what is still missing. In Creator, we have already have a good consortium who is covering the whole value chain, including the logistics. However, if we do one circle with the materials in our tiny world, this won't turn the circularity in Europe, but we need to collaborate with the other projects, and that we are doing already today here. As you have seen, we have similar targets, but we have different approaches, and I think we can all learn from each other today in this framework of the Horizon Results Booster. But we are working on this also in the Plastic Circularity Multiplier, where we have quite a few projects working together on the circularity issues from very different perspectives. But what is really necessary, and this is also something Mohammed already pointed out, we need all the actors from different communities together if we aim for circularity. So really the design for recycling is needed. And therefore we need to take all the communities along the value chain with us, from the designers to the converters and the recycling communities. And then we are, of course, very thankful for the European Commission for the funding we have gained and what we have seen, how much funding has spent to circular economy topics in the Horizon program already. And we have seen that this is already also drafted in the new Horizon Europe program. So we're very happy to continue on these topics together with the partners here. Next slide, please. So I would like to summarize just with my contact details. So if you have any remaining questions we can't answer today, don't hesitate to come back to me. And you can, of course, follow our results on our homepage and our LinkedIn channel. And here you see as well a picture from Fraunhofer ICT, as Esther already showed. This is at the bottom of that building. She was on the roof of the building with her consortium. This was before the Corona time, and we are looking forward to meet physically even maybe this year. Thank you a lot for your attention. I don't know if we have questions already now, Marianne.
Thank you, Irma. Very interesting presentation. Very nice pictures as well we are seeing today. Indeed, we have several questions for you. The presentation raised very much interest among the people connected today. So the first question is, by using LIPS, you are sorting different polymers and into brominated flame retardants. Sorry, because I don't have a technical background. Sometimes it's difficult for me to pronounce those technical words. So again, by using LIPS, you are sorting different polymers and into brominated flame retardants and non-brominated flame retardant fractions. Is this correct? If so, what concentration of bromine are you considering to sort these fractions?
Yes, this is almost correct. Thank you for that question. So I wasn't maybe clear enough on that. So the LIPS sorts on the chemical species of bromine. So what we do sort is non-bromine and bromine containing. We don't sort different polymers among them. This is done by other techniques like NER or middle wave NER. You can sort the polymers, but we separate between bromine containing and not bromine containing. And we do make those models, as I shown in the moment, to be able to do that on the threshold of 1000 ppm, which is now in the moment the concentration where you have to incinerate the material or not.
Thank you, Irma, for your answer. We have other question, again, regarding this policy and legislation. What is the main legislation issue in your project for the later exploitation?
Yeah, what we have seen in the moment, that is the waste legislation, which will cause a bottleneck later on in the exploitation. And I think this was pointed out by Mohammed as well. So if we look on the end of waste criteria, they are now, the legislation today is covered on national level. And if we are now transporting materials from one country to another, this is a huge problem, as some countries do classify the recycled polymers as a waste and others as a material, and then different legislative thresholds for the material amount which is allowed to be transported are taken into account. And if we could agree on end of waste criteria for plastics EU-wide, this would of course make for all of these projects the exploitation across the borders much easier, as we need to transport, on the one hand, the polymer waste coming into the recycling pad, but also to transport the recycled polymers from the recycling plants back to the later end users. So I think that is the main bottleneck in the moment.
Thank you, Irma. One final question before we move on to the next presentation. This, I think, maybe is a common question for all projects, but in this case, we will address this question through this presentation, through the answer of Irma. In what category of recycling technologies does Creator allocate itself? Is it a physical or chemical technology?
Yeah, so we differ between physical and chemical technologies, as you said, and we refer here to a classification, what was actually published by the IVV, and they are talking in the circular flooring project later on. We see that the physical technologies are those where we have the polymer chain being a chain throughout the whole recycling chain, and the chemical technologies are those who are depolymerizing that chain. So therefore, as we are kind of dissolution technology, this is still a physical technology. We do remain the whole polymer chain, we do dilute it, and we do remove the materials around it, but we don't destroy the material itself. But this is certainly something we could discuss later on as well among the other projects. There is a lot of confusion on that topic.
That's why I was saying, I think maybe this is general questions for all the projects. Before we move on to the next presentation, thank you, Irma, very much. Just a quick reminder, there has been 1 hour since we started this webinar. This session is being recorded, so you have to leave because I know you are quite busy, all of you. This session is recorded and will be available on the website of the projects and YouTube channels. So we will send a follow-up email with all those informations later. Regarding the next presentation, we have Thomas Diefenhart, Associate Scientist at Fraunhofer IVV, and the next presentation is entitled Circular Flooring, Recycling PVC from Post-Consumer Flooring Waste. Thomas, the floor is yours. Thank you.
Thank you very much, Mariana. I hope you can all see me since I don't see myself in the screen. Thank you for inviting us as well to present our project here. You can switch to the next slide. I apologize in advance for some mistakes, or if something appears double in the slides. I thought I would present myself the slides, but it's not a problem. We will get through this together. So circular flooring, the project aims to produce new products from waste PVC floorings and to safely treat legacy plasticizers. Next slide, please. The project is a project that lasts for 4 years. It's funded as the other projects under the Horizon 2020 funding scheme. And the coordinator of the project is Dr. Martin Schlummer from Fraunhofer IVV. Next slide, please. The project objectives is to enable a circular use of plasticized PVC from waste flooring by developing a recycling process which eliminates legacy phthalic acid esters that are not conform to the EU REACH directive. It does so by developing a process for the recycling of the legacy phthalate-free PVC and prevents the PVC thereby from getting landfilled or incinerated, which is what is being done with it at the moment. It aims to demonstrate the circularity of this PVC in flooring and the applicability of the phthalate-free plasticizers that are being produced from the legacy plasticizers. And it wants to assess an environmental health and safety impacts and, of course, the techno-economic feasibility of the whole project. Next slide, please. Thank you. We have 11 partners from 5 different countries and 7 linked third parties, which is a mixed consortium from research institutes, universities, and manufacturers of PVC. Thank you. Next slide, please. This one you can jump. It's just a repetition of the one before. Thank you. So the process in general is, or the loop we're trying to close is that the PVC enters our loop by being collected from the consumers, or it's post-consumer PVC. It is then recycled by the Creosote process, which is a solvent-based process I will describe in detail later on. This process, though I can already say now, separates the legacy phthalate acid esters and the PVC. The PVC is recycled and then brought back into new flooring, and the legacy plasticizers are catalyzed by catalytic hydrogenation and made how do you say, are made safe again, and then are re-implemented as well into the PVC, into the new floorings with additives. The next slide, please, will show more in detail our tasks that we have in our project. So we can start from the top, where we can see that the post-consumer PVC or end-of-life PVC is collected and sorted. It then gets to the Creosote plant, where it is recycled by the Creosote process. Here we have the two streams, the blue one, which is the PVC, going back to reprocessing, and the plasticizer stream, the yellow one, being where the plasticizers are catalyzed by hydrogenation, and then the safe plasticizers are then again brought back into the new floorings, which are then supposed to re-enter the market. Next slide, please. So the two key technologies I already mentioned are the Creosote process and the hydrogenation technology. The Creosote process is a solvent-based recycling technology which enables these resources to be conserved by mainly separating these two, let's say, resources, the PVC and the plasticizers. It uses specific solvent formulations that do not contain hazardous substances as defined by the EU chemical legislation. And the PVC is dissolved from the flooring formulation. It is then precipitated and dried for the reuse. The hydrogenation is a catalytic hydrogenation, and it converts these phthalate esters to safe plasticizer alternatives. Next slide, please. So more in detail for the Creosote process, as mentioned very fast, it enters the process. The waste enters the process and is solved. It is then cleaned in various cleaning steps depending on how dirty the input material is. Impurities are taken out of the polymers. The polymers are then precipitated with an anti-solvent and are then dried. Even in the precipitation step, impurities can be taken out depending on how it is performed. And the solvent that is used is regained in a closed loop. So it's like a closed, it's a closed process basically. And the product or the finished polymers can be produced as powders, granulates, and as pretty much any tailor-made form. In the PVC industry, the PVC is applied as powder, therefore our product is a powder, as it is produced after our process. And within this process, a re-additivation or stabilization of the PVC is possible. Next slide, please. The stage of the project at the moment is we just finished the laboratory scale, or we just proved everything on laboratory scale and are moving on to the pilot scale or pilot plant scale. And next slide, please. For this, we are producing, or we are building, a pilot plant, which is almost completed in the building, but is not yet filled with all our equipment. So this is the stage we are at right now. We are building the pilot plant to be able to demonstrate that this process also works on a larger scale. And since we have proven with our partners that it is also economically feasible and worth it, we also have to prove this, or want to prove this, on a larger scale. Next slide, please. Regarding the results, I'm sorry, here the slides are only very general. I will try to give a little more detail. So in the first place, we identified that there is a lot of PVC in the market, around 360 kilotons in Europe, that can be collected. Realistically, only about 80% of that is available, because there's always PVC that is not that you wouldn't be able to collect or get. Therefore, we're talking about 290 around kilotons of PVC available, and of this, realistically, with current efforts, we said that around 8 to 10%, so maybe around 225 kilotons could be recycled with this technology, and are available without performing too high efforts or too high efforts, let's say, which would then be too expensive. And the main countries in which the PVC is available are France, the UK, and Germany. The PVC in the last months has been improved by especially the particle size, because the tear strength, elongation, and heat stability were always good characteristics for it to be implemented into new floors. But we had some issues with the particle size, since PVC powder is very fine powder, and we are now at a stage where we have particle sizes of below 500 micrometers, and this is around what the industry would accept, even though it would be best to even have smaller particles, which we're trying to get or to reach. And as you can see in the right picture, the dark sample is the recycled PVC. This is a second issue that we are having, which is I think in all recycling industries the case, that if we have a mixed input, as you can see in the left picture, the output is going to be dark in color, and PVC generally has a lot of decorations on the surface. So our PVC could not or will probably not be used for top layers, but only for middle or low layers, since the quality and the characteristics are good, but it's almost impossible to color the black surface, or it has less applications or less places where you can apply it. Next slide, please. The hydrogenation technology, I'm not an expert in this since our partners are doing this, but what I can say is that the low molecular weight phthalates are catalyzed, and these are limited by the REACH legislation, and they are converted into cyclohexane decarboxylates, which are similar to the DINCH, which is a plasticizer which is applied in very large scale in the market. And the good thing is that these have little migration characteristics and low toxicity level, as well as a high compatibility with the PVC. And there is a whole, we are not aiming on producing a new, or we're not producing a new phthalate, a new plasticizer by this catalytic hydrogenation, but it is a plasticizer that is already on the market, and therefore we hope to not have to do a whole new registration for this plasticizer, but this is something we have not yet tackled. Next slide, please. The advantages of the Creosote process, as already mentioned, are especially that this solvent-based technology separates the substances, in our case, the PVC and the phthalates, the plasticizers, and thereby it makes it possible to retain these resources and to keep them in a circular economy. It uses solvent formulations, as already mentioned, that are not hazardous substances, and they therefore do not pose any risk to users or the environment. And thereby it helps the EU to reach its goals of establishing a circular economy in Europe. Next slide, please. The benefits for the European society are a contribution to establishing a circular economy, the reduction in consumption of primary resources, the removal and safe destruction of legacy plasticizers from the plastics, and recovery of these valuable resources of plastic waste, since up to date these are only incinerated or landfilled, similar to the ones that were also, or similar like to the other projects. Then the reduction of greenhouse gas emissions and the creation of new business opportunities, since this is a field and we are aiming on, at the moment in this project, it's aimed at that only the PVC regarding these plasticizer, these phthalate esters are supposed to be recycled with this technology. It's not aimed at all PVC flooring that has plasticizers that are totally fine and legacy free. Therefore, it creates new business opportunities with the circular value chain. Exactly. Next slide, please. This is the end of my presentation. Thank you very much for your attention, and I would be happy to answer any questions. And I also want to encourage you to visit our website and to download the files we have there to see the work in more detail that we do. Thank you.
Thank you very much, Thomas. You mentioned during your presentation the Creosote process. I think this is a common process for most of the projects involved today. There was a comment on the chat by Lane Tanger, expectation for a scale up the Creosote into demo plant around 3 years and a full scale plant 6 years. I suppose you are concerned about the exploitation of these technologies and coming into our reality by these demo plants.
Yes, sorry, can you repeat? What's the part of the question of that comment?
Yeah, no, I'm going to link that to the following question that the same person, Lane Tanger, asked regarding the technologies you show. It's just pointing out that the Creosote process is a common space for most of the project, and that the idea is to have that process become a reality in a full-scale plant in 6 years. For the question,
absolutely.
Yeah, sorry to interrupt, Thomas.
No, not a problem. Yeah, I just wanted to say regarding this technology, there are some fields of application where it has already proven to be very useful, and therefore the application on larger scale is absolutely true, has already been established, let's say, even though it is something that is not the same for all the fields. Now, if we talk about the PVC on a larger scale, the Careersoft process has not yet proven that for PVC it can work as well, or it works as good as, for example, polystyrene, which has already been proven, or multi-layer packaging, and therefore we will have to first show this with our pilot plant, but we are quite confident that it will be successful, and
Thank you,
but
Thomas.
we will also be happy to present this work once we have the maybe in 1 year, once we have the pilot plant running, and exactly.
Thank you. We have some questions for you. Probably we won't have the time enough to answer them now, maybe on the panelist session, but here is one question for you. What is the percentage of total additives which need to be incinerated coming from the PVC flooring?
The percentage of the additives?
Of total additives, yes.
I'm not really sure what is meant by the total percentage of additives that need to be incinerated.
Maybe we can move just to the next question, and we can take a time to answer that question.
But no, wait, I can try to answer. It's not a problem, Mariana. If I have a second. So the second question I just opened the chat, was what is finally the percentage of PVC put back into the market? So our PVC we get, I can at least for sure share that we have from the flooring input that we get, we have around 60% pure PVC, and of this 60%, we have around 95% that we regain and that we reproduce as PVC that can be re-implemented into the floors. So the main issue is that, regarding the volumes, that already a lot of input, or that the PVC is a very small amount, let's say, if you, depending on how you look at it, but that the 60% that is in the old floors is not such a great number, let's say. But from this 60%, we extract almost all of it.
Okay, thank you very much. I think that was quite clear. There are more questions to be answered. As I said before, I'm afraid we don't have still the time to answer them. Maybe in the panelists and interactive session, we will try to answer them. And if not, as we mentioned before, we will gather all those questions and answer them after this webinar session. We will move on to the last presentation now. Thank you very much, Thomas. We will move on to the REACT presentation. REACT is a project addressing the management of waste acrylic textiles coming from other awarnings and furnishing. And this presentation will be led by Roberto Banucci. He is multisectoral R&E department manager of Centrocode. Roberto, the floor is yours.
Thank you, Mariana. Thank you all. Okay, ladies and gentlemen, good morning. First I would to thank you, the Horizon Results Booster and the NONTOX project and all other projects to this initiative to welcome REACT on this. Really, we are not focused on plastics, but on textiles, even though acrylic fibers that we are working on are a kind of plastics, of course. I'm Roberto Banucci. I'm responsible of multi-sectoral research and innovation department of Centrocode. Next slide, please. Just a few overview of Centrocode. Is a technical textile center located in northern Italy, near Milan, and Centrocode is the coordinator, project coordinator of REACT. Next slide, please. Thank you. This is the partnership and some general information about the REACT project. With this consortium, we try to have the full supply chain, including the closed loop on textile in a circular way. That means that we have a partner producer of manufacture of goods, fabrics for tents for outdoors, that is Para Tempotext, is a European leader on this sector. Then we have Centrocode Ghent, that in collaboration with the University of Bergamo and with the partnership of Ghent University, and the other partner is Soft Chemicals. We are trying to remove chemicals from waste, acrylic waste. Then we have CETI in France for the mechanical recycling of the fabrics removed by chemicals, and yak spinning in Hungary to spin again the fibers in order to have a new yarns for production of new textiles, even again in acrylic fiber. The project is lasting 3 years. It's about 3.3 million euros. Next slide, please. I think that you all know this well-known picture from Ellen MacArthur Foundation. This is in order to fix that all the huge amount of textile entered into the market are more or less 3/4, 73 in this slide, 3/4 of these are landfilled or incinerated, and only 1% of the material, used material, textile material, is reused in a closed loop in the same circle, in the same supply chain. As you can see, the textile, when we speak about textile, we are most are clothes for our normal life, but there are also several other parts of a textile, like accessories and so on, and in particular technical textile for several in sector or for other application in human life with specific characteristics. These are the acrylic fibers for outdoor awnings, umbrellas, and so on. Next slide, please. Which is the challenge of the REACT project. We are, as I said, focused on technical textiles that are particular technical characteristics that allow these fibers, these acrylic fibers, to be used in particular in awnings, umbrellas, and furniture for outdoor. Because there are technical characteristics as UV resistance, strength, mechanical resistance, and also water resistance to exposure to the weather. Yeah. More than 90% of the fibers used for this kind of sectors are made in acrylic fibers. So we focus on these, and around 11,000 tons of acrylic outdoor fabrics are produced each year. And it is estimated that 2.5 million of awnings are installed in Europe. We estimated that the production of 8,000 tons go to the waste, landfilled, the most per year. So we focus on this, and there are until now not recovered because we used some compounds, chemical substances, in order to have performance, high performance, with a long duration for several years, because the use is the lifespan of these goods is about between 80, 10, 15 years. Next slide, please. Okay, thanks. The objective, the goal of REACT project are to remove at least 90–95% of the chemical substances that are in the fabrics, and to treat up to 19% of the impurities obtained. And we want to, as I said at the beginning, to have a closed loop producing yarn with up to 100% of recycled fibers. The objective is to reduce the amount of acrylic incinerated or landfilled by 30% at the end of the project. The project is in its second year. I can say that we already achieved the success to remove more than 95% of the chemicals over the fabrics. And so we are approaching with our goals. In addition to help to finalize the sustainability of this sector and this activity, we'll study wastewater from the finishing removal in order to recovery the products used, and in this case, reducing the pollutant load of this wastewater. And one of the partners, Soft Chemicals, is also studying a new, more green and sustainable finishing, substituting the hazardous chemicals that are used, are still used. I think that's all for my presentation. Next slide is thank you for your attention.
Thank you very much, Roberto, and congratulations for the results you are already achieving in your project. We have now our interactive session where we would like to hear all the panelists answering several questions, because as we already mentioned before, there are several questions common to some of the projects or all of them. And I think it would be good to see all the panelists discussing how we address some aspects, common and joint aspects. Before we do that, I think we have questions for you on the chat. I see one from Katie Mirarova. We are granting authority and oversee the presenting project. Can I have the floor for 2 minutes after you take some questions on the last presentation? I don't know if this is possible for my colleagues on the technical side to leave Katie Mirarova to ask herself in directly. If not, we will move, or while we wait for that, we will move on to the next question. This is not only for Roberto, but we will take the opportunity for you to explain the first. Have you encountered any VOC and others emission from the recycled materials? In other words, does the final product smell like most recycled products? Do your processes reduce polymer odors?
I can try to answer. It's not the problem of the REACT project, because we remove chemicals, of course, with a chemical process. We didn't find anything because any VOC, because the process that we use is industrial processes. That is the formulation in order to remove the chemicals. That is our study, our let's say experience, results research, and then we use a mechanical recycling for fibers. So we have, I didn't perceive any information about VOC, but you have a time to eventually repair on this. This is from my side. I know that is not for the REACT project really this question.
Thank you very much, Roberto. I see now that all our speakers and panelists are switching on their cameras to participate in this interactive session. I didn't receive an answer regarding the question I point out before of Ms. Medarova. I certainly encourage you to do that through the chat if you can, to write down your question so we can address that with our panelists. Thank you all again for joining this session. Thank you, our panelists, for participating today. We will move to this panelist session, this interactive session. Please continue asking questions through the chat so we can address that with the panelists. There were several questions that we didn't answer before, and we will try to address them all now. The first question is for
Marianne.
Yes.
Just for Katie, I think she asked just the floor to say some words from the European Commission. And before we going now to the questions, I would say let's give Katie the floor and give her the opportunity because you're funding all these projects, so that is very good.
Yes, certainly. While we try to solve this problem, because on the technical side, I already asked the people managing to try to give her permission to address those questions while we try to solve this technical problem and allow her to ask her questions directly to the panelists. We will try to answer the questions and then move to Ms. Medarova herself to ask ask their questions herself. The first question then will be for you, Esther. There was a question on the chat regarding the target of bromine reduction to 0.4%. What is your concentration limit based on that?
Yes, thank you for asking this question. Well, as I already pointed out, we have to start with we're starting with 12% of brominated flame retardants in our test samples, and we have to go back to 360 ppm of the brominated flame retardants. So that is that reduction that we have to do, and we are almost there, not completely, but almost.
Thank you, Esther. I think we can hear now Ms. Medarova is only just she has to raise her hand, and now I think if she unmutes herself, she can speak out loud and ask the questions she wanted to ask.
Yes, hello, can you hear me?
Loud and clear.
Yeah, thank you so much for this opportunity. I just wanted to say a few words. Actually, there are no questions. It's mostly to thank the projects for coming together for this meeting and for these presentations, and to thank the Result Booster for organizing this dissemination event, because as the projects know, we in the executive agencies that are the granting authority for all these projects have been reinforcing the message about clustering and optimizing synergies and complementarities between projects, especially in the plastics field. And therefore, this is an important event for us. And exactly as in the past, but also in the future, we'll continue also to bring these projects together. And what is new, I would like to announce here for the participating projects, but also for your participants at the webinar, is that under the 2020 call for proposals under Horizon 2020, we have another set of 10 projects that are working also in the field of plastics recycling, reuse, and decontamination, mostly related to multi-layer packaging, but still I think most of the technologies that are going to be tested and validated are similar or the same even. So it's very important to keep track also of all the new projects that are now starting. And for your information, we will do a joint kickoff meeting of this project in September, which will be accompanied with a clustering meeting as well. So we will invite you as well. And last but not least, remember that new opportunities are coming under Horizon Europe program, and the new calls were just recently launched. Several of them are directly related to plastics, innovation in value chains, also electronics, textiles, and other related fields. So check the portal and to invite you cordially to our information days that are taking place on the 6th and 7th of July, when more information about the upcoming topics will be provided. And on the 9th of July, there is also a brokerage event where maybe you can also come together and look for more partners and then possibly find opportunities for working more together in the future. So with that, thanks so much for giving me the floor. Congratulations one more time on your progress and for coming together, and looking forward now to the discussion. Thanks.
Thank you very much, Ms. Medalova. This is an interesting point that she raised. All these projects here are collaborating on the Horizons Results Booster, but obviously there are more initiatives collaborating as well together. I certainly invite you to visit the Plastics Circularity Multiplier website, where most of those projects, if not all of them, are collaborating together to find and solutions for those plastics recycling challenges that we are addressing today. We will continue now with those questions that weren't answered before, if you all agree. I think this is a question for Thomas again. This is a question from Tom Caris. We have regularly seen in the past that the substitute of a regulated substance becomes regulated later on also. Example, penta-BDA, deca-BDE, DBDP. What is the lookout for the lactate you produce by hydrogenation? Are you not concerned this will happen?
Thank you for the question. Yeah, it's a really good question, and also really thought through, because of course we are aware of this, and I think it can happen because it has happened in the past, that also these how do you say, this product that we are producing, these plasticizers that are now so-called safe, maybe in the future will be classified as non-safe legacy plasticizers, and then we will have to react in another way. The good thing is that through this Creosote process, we are not dependent on this hydrogenation, in the sense that first of all, we are separating these two resources. For now, we can call them resources because both of them, because also the plasticizers can be reused if hydrogenated. It can be that in the future we are not going to be allowed to hydrogenate the plasticizers anymore, and we will only be using the PVC as resource. For sure, I think that is one, I think half of our answer, because that means that we can, the PVC will always be able to reuse, and it will somehow have to be recycled. And so far, we don't have any other better alternative than this solvent-based technology, as far as I'm concerned. And therefore, it gives us like a small outlook, because the plasticizers do not have to be recycled and re-implemented. The plasticizers can also be safely destructed. That is also, there are other alternatives. They can be the chemical reactions that take place there can also be changed. Therefore, there is, I think, a lot of space we can play with there. But I think it's a very good question to keep in mind, because this can for sure happen.
Thank you, Thomas, for your answer. We will address now questions for all the panelists. Maybe we can take the lead. Just raise your hand and unmute yourselves, and maybe you can answer those questions. There's a questions for the projects, for all the projects, using solvent-based technologies for waste electronic and electrical equipment, C and DW and ELV waste. Is it also suitable for separating and recycling wire and cables mixtures? There is a question from some of you. I don't know who wants to take the lead to answer that question. I think Irma raised her hand.
Yeah, I can maybe start on that. Yeah, for sure, the dissolution technologies, they are dependent on the material quality we are getting in sense of the waste. It has to be quite pure in the polymer we are purifying, as this polymer is melted. So the dissolution step takes place at the melted polymer, and there we can treat polymers with similar melting temperatures. But looking on the cables, and I think this refers to PVC cables, this will be quite difficult, but maybe circular flooring has more details on that if it's on PVC. Maybe the participant can give more details on which kind of cables they are looking at.
Maybe I can just add some words to Irma. So I think you explained it already quite clear, Irma. And what I also would like to stress is that for each polymer, you need different conditions. So the type of solvent can be different, the process can be different, the components that have to be removed. So that is that you need a dedicated process for each plastics. But in principle, the dissolution technology is able to doing that for different types of plastics. So that is just for PLAST2bCLEANED. We are now focusing on ABS and HIPS, but our goal is to do that for more types of plastics. So we have to look then what has the best impact also for the European Commission for the next focus on the polymers.
Yeah, maybe I can add something to this as well, since we worked with this Careersoft process and also on other materials on other projects. I remember where we had basically Katie also just mentioned it. There are other projects where multi-layer packaging are also using this technology, and there is. I remember we had a project with aluminium foils that are used for packaging, and they have PE layers or PP layers on top of that foil, and that is not a problem to separate the plastic from the cable, wire, or anything, any metal, let's say. Therefore, it is possible. I think the biggest issue is the cost, because of course this technology is more expensive than let's say like sorting or shredding or these kind of technologies.
Thank you, Thomas. I think it was clarified that they were referring to PVC, and I think Irma would like to say something out loud.
I don't think so, but yes, it was clarified by Sophie. Thanks a lot for that clarification. And I agree totally. We need to look in detail what to do with the cables. This is an issue coming up. It's a huge amount coming from the construction sector, and definitely there is no solution for the package yet. But this is, I think, when we have solved out these tackles we are having now, this is the next step to take, to look on those multi-material solutions there. Thank you.
Thank you to all of you for all those answers. We have another questions. In the case of plastic parts are painted or coated with a metallic layer, for instance, in electrical household appliances, would some of those advanced recycling technologies be needed to properly recover the materials? Or are currently mechanical recycling solutions able to properly recycle those materials? I don't know if you would like to answer that question. Maybe someone would like to raise. Esther, I think you're muted.
Yes, thank you, Marianne. Just to start, these are typically the impurities that we have all to deal with. So plastics are contaminated with all types of impurities, and one of them is coatings. So that is when you're looking now for the PLAST2bCLEANED, we started with test samples, and we go now to real life samples to check how the process worked with real life samples, and then typically coatings, but also all types of other impurities, they have to be removed in this process. And PLAST2bCLEANED used several absorption technologies to remove those components that we do not want in the end product.
Thank you, Esther. I don't know if the rest of the panelists would like to say something. If not, we can just move to the next question. There is something that we have all addressed in the presentation, that is the implementation of new policies regarding end-of-waste circularity policies. We spoke about the REACH current policy. There's a question regarding the policy recommendations. Some of you indicate that the end-of-waste criteria in Europe is an issue. Did some of you realize a benchmark of how end-of-waste criteria are applied in Europe countries?
Actually, to say it from PLAST2bCLEANED, we haven't looked into detail yet. So, but we know, of course, that the end of waste criteria that is an issue, and there are different criteria in Europe. So, but actually, we have to comply for this project. We have to comply with the REACH legislation. So we really looking at the technology solving the problems, and we ask the policy to check or to solve those issues with the end of waste criteria. So I think this is typically questions that should be taken up by the policy, and not by the individual project. Furthermore, Marianne, I saw also a question in the chat, and it was already partly answered, but I think that it's nice discussing that here is if investors are willing to invest in these type of technologies. And I think it's nice to also to see for the opportunities that to see the panelists here.
Yeah, before we move on to that, I don't know if Irma raised her hand. I don't know if you would like to move on to the topic that Esther just raised, or should we answer first that questions regarding the policy recommendations?
I had just a further comment on that end-of-waste criteria. So this is not applied on European level yet for the polymers, and this is the issue in the moment. They are applied at national level, and for example, in Germany, even at government level in the single Bundesstaat. So it's really a matter to act there jointly at the EU level. Maybe to continue a bit on the next question on the how the end users are going to invest, how willing they are to invest in the materials. I think yes, they are. Certainly in the moment we have an economic situation where polymers are wanted, but I don't see that this is long staying. In the moment we have a lack of materials on the market, but when we are looking on the policies for the production of petroleum-based materials, they are still quite low cost. So we need to tackle that issue also from the policy wide. So we have to have a certain price for those materials, recycled materials, to be able to run the processes. But certainly, yes, I think all the recyclers I've been in contact with, they are looking forward to new technologies and to enhance the their processes. And I think it's quite impressive also how many of those are already participating in these projects, and they have an own contribution on these projects as well. So yes, I'm sure there is a willingness, but it takes still some time. We need to show first results.
Thank you. I don't know if you would like to say something. I see Muhammad unmuted himself.
Yeah. I just wanted to add to what Irma just mentioned. I think recyclers are really looking for new opportunities, looking into the different consortiums and the companies that we have been talking to. They are really looking out for the new opportunities. The investment point of view is a little bit intricate here. Investors, they look for long-term guarantees. Tom Karras raised a very important point that what you consider now as legal or fine, the next day you can see that it will turn out to be as a non-relevant or additive or something that needs to be removed. So that creates a little bit of lack of trust for the investors. So I think from the legislation's perspective, I think that is also very important that you have long-term policies, and that gives much more confidence to the investors in investing new businesses.
Thank you, Muhammad. I saw Esther unmuted herself.
Yeah,
Yes, please,
well,
Esther.
actually, I agree with both Irma and Mohammad. I was also, I'm also, praying for long-term stability for the field for recycling. And in addition, I would like also to point out that the cost of the plastics made of virgin oil is actually far too low, because we do not pay the cost due to the environmental burden. And actually, when you are going to look for the price, including the environmental burden for the virgin plastics, they are then, what you see is that they are higher than for the recycled plastics, including then the environmental impact. And therefore, there should also be, I would pray for some price leveling between the virgin plastics and the recycled plastics, to include also the environmental burden in that. And that it will be a story of some longer term, but we have already to think about that, how to do that, and make a better competition between the plastics from virgin oil and the plastics, the recycled plastics.
Thank you, Esther. I think Thomas unmuted himself. One last words from Thomas before we wrap up, because we only have 2 minutes left before having to close this session. So Thomas.
All right, sorry, I just wanted to add in also another argument or another point, which was basically just that. No, but thank you for the other points. I think they were super useful and they're all right. I just wanted to share that I think from an investor's point of view, or maybe before, I see also a really big growing interest from the investor side. From some investors that also are interested in this production. I think one thing that was helpful, and if people here are listening and interested, they can look up polystyrene loop, which is basically this technology applied to polystyrene used from construction and demolition waste, and is a plant that has been opened, there was at the grand opening a week ago, and there you can see that it's growing. I think one point that Irma pointed out, I think during her presentation, is the fact that it's difficult to ship these plastics because they are from one country to another, because they are characterized as hazardous substances in some countries. And therefore, an investor also needs the guarantee. Of course, there will always be waste, but he needs a lot of quantity to recycle. So he needs also the guarantee that he can maybe look in other European countries to buy his waste or resources instead of his own country only, if he needs a couple of thousands of tons a year. And yeah, I think that's also a very important point regarding the legislation, that it should be more easy to ship these goods if they are intended to be recycled in a decent way. Yeah, that's only just a point I wanted to throw in there.
Okay, thank you very much, Thomas. I'm afraid we have to close now the session. We have a question for you before you leave. If you can take a couple of minutes to answer that question, to express the degree of satisfaction on the presentations today, if you were interested in what was shown by the speakers. To the speakers, thank you very much for taking the time to present all your wonderful results from your projects and the work you've done so far, and the technology that is going to be probably the future for this circularity challenge that we all are addressing these days. I think we are already receiving some answers to those questions. Thank you very much for joining us today. This was a session organized and led by the Eurasian Results Booster. As I said before, I encourage you to follow all the projects on their social media channels and websites, to contact the panelists through the email addresses that they provided, and to check out the website of the Plastic Circularity Multiplier, where more joint actions will be carried out to join forces to address that challenge of plastic recycling. Thank you all very much for today. Hope to see you again in the coming session. It was great to having you all online. Thank you very much. See you next time.
Thank you very much. Thank you.
Thank you, Mariana. Bye-bye to all.
Thank you.
Thank
Bye-bye.
you.
Hi, Line.